Okay, so today we're going to talk about graphing lines, graphing a linear function, which is the same thing as graphing lines. So a linear equation in two variables is going to be in this form, ax plus by equals c, where a and b do not equal 0. I just wrote a fancy symbol there for and, although it looks really weird. And by the way, this is what we call the standard form of a linear equation. So this is standard form. Okay, and then a solution to an equation in two variables will be an ordered pair, and it will be listed like this, x, y with parentheses, and that order matters. And a linear equation in two variables will have an infinitely many solutions. So this is kind of stuff that we have gone over before. That's why it says up here, recall. We went over this in Unit 2. So guidelines to graphing linear equations. The easiest points to find, and I was making reference to this as we were going through the last section, is the x and y intercept. So you can always create a table of values, and then the best thing to do is just, we only need really 2 points to draw a line, but we should have a third checkpoint. And so if we use x equals 0, and we solve for y, we're going to be finding the y-intercept. Where does the y-intercept get graphed? On the y-axis, exactly. And then if we find the x-intercept by substituting y equals 0 and we solve for x, where does the x-intercept get graphed? On the x-axis, okay? And then we'll plot and label the points, and we'll graph the line. This is where a ruler could also be helpful. So I'll get out my fancy, cute little ruler. I love this one. I got this at the bookstore. It's metal with cork on the back side for traction. And then you graph the line by connecting the points. By the way, you can use your calculator's table of values to check these as well. So if I wanted to make a table of values, we could use the idea of the x and the y intercepts. So if I plug in x equals 0, what's the only thing I will have left? 1. So that's one ordered pair. 0, 1 is here, 0, 1. And look at that, I labeled it. So on the y-axis, we call this point the y-intercept. Now, if I wanted to find the x-intercept, I could replace y equals 0. So I would set y equal to 0, and I could solve 2x plus 1. How could I solve for x? Once I set y equal to 0, what would I do? Minus 1. I get negative 1 equals 2x. Divide both sides by 2. And I get negative 1/2, x equals negative 1/2, and negative 1/2, comma 0 would be my x-intercept. Whenever you have y equals 0 and you solve for x, you're getting the x-intercept. You could also just plug in a few points. Maybe you plug in negative 1 and 1 as 2 more points to plot. So if I plug in negative 1, I have y equals 2 times negative 1 plus 1. That's equal to negative 2 plus 1 equals negative 1. So negative 1 is here. You could label that, negative 1, negative 1. Got a little crowded, so I didn't label my x-intercept. And then if I plug in 1, I get y equals 2 times 1 plus 1. Does anybody know what that would be? What is it? 3. Good. 1/3 over 1 up to 3 right here, 1/3. Now that's 3 points. Technically I only need 2, but it's always a good idea. The more points I have, the more accurate my line will be. So once you've plotted some points, you can connect them, and I would draw arrows on the end. Now if you want to get super fancy, you could always write y equals 2x plus 1 next to the line, Especially that could be helpful if you're graphing multiple lines. I just want to show you a way that you can check it. Now, of course, I really do. I'm not asking people to become dependent on the calculator, but if you do have a graphing calculator just for fun, because this one is written as y equals 2x plus 1, remember that in order to graph, you would go to your y equals, you could clear out anything else you have in there, and you could type in 2x plus 1, and then graph. Remember, our window is set up all weird, and that's why we're not seeing a window that, you see how this graph does not look like this graph? If I want to make it look the same, I could press zoom, standard, and that will get me back to the 10 up, 10 down, 10 over, 10 over, which this one is pretty much the same exact viewing window. And now it does look the same. And then how would you see the table of values? Do you remember how to get to the table? Yeah, second table. And this table of values is set up to count by 100. So I could go back to my table setup, second table setup, and I could start at 0 and let's just count by 1. That's typical how you'll see most tables. Most tables are going to just count by 1. Okay, so then we go back to the table, and some of these same points that we found are going to be on the table, except for the 1/2, because my x's are counting by 1 and my y's are actually going up by 2, and that's to do with the 2x situation. Okay, any questions on that so far? All right, so in order to graph the next one, the first thing we can do is plug in x equals 0 and then plug in y equals 0. We're going to find our y-intercept and then our x-intercept. I just abbreviated that. So if you plug in x equals 0, you see what ends up happening. You get 0 plus 2y equals 4. How would you continue to solve to find your y-intercept? Yeah, because 0 plus 2y is just 2y. So you get 2y equals 4. You could divide both sides by 2 and you get y equals 2. So 0, 2 is my y-intercept. I go here, 0, 2, and there's my y-intercept. To find my x-intercept, I'm going to substitute y as 0. If I substitute y as 0, I end up getting x plus 2 times 0 equals 4. So what does x equal to? Yeah, x equals 4. Does everybody see how we got that? So 4, 0 is here. Now, if you wanted to get this in the form where you could also put it on the calculator, what would you actually have to do to get it into this similar form where you have y by itself? Any thoughts about that? How would we solve the equation for y? So I have the equation x plus 2y equals 4. And by the way, this is coming up. This might be on the test, right? How do we get y by itself? And how do you move everything over? What would you start with? Subtract the x, right? So we get 2y equals negative x plus 4. And how would we get y by itself? So opposite. What's happening between the 2 and the y? Yes, we would divide everything by 2. So I'm going to divide that by 2, that by 2, that by 2. I get y equals, see how y is now by itself? What is that? Negative x over 2. What number is in front of x? Yeah, so it's negative 1/2 x plus 2. Do you see how I got the negative 1/2? Now, if I want to put in other values, maybe I go negative 2 and 2 as opposed to 1. Because if I put in a negative 2 in here for x, what's going to happen if I take half of a multiple of 2? Half of 2 is 1. Yes, half of 2 or negative half of 2. So if I plug that in, let's do negative 2 first. Y equals negative 1/2 times negative 2 plus 2. negative times a negative is a positive. Half of 2 is 1. 1 plus 2 is 3. Okay? If I plug in 2, anybody know what I would get if I plug in 2 and I'm running out of room? Y equals negative 1/2 times 2 plus 2. It's negative 1/2 of 2. Negative 1, right? Plus 2 is 1. So these other points, negative 2, 3, negative 2, 3, and 2, 1 should be on the line as well. 2, 1 is here. 2, 1. You see how all of my points will form a straight line. If I have found them correctly, if you find that your points are not forming a straight line, that is an indication that one of the points is incorrect. Okay, and then since I have y by itself in this equation, if I go to my graphing calculator and I go back to y equals, I could type in negative 1 divided by 2, that's negative 1/2, x plus 2, and I press graph. And I'm just using that to check. I don't want you to become dependent on the calculator. I want to know that you can graph without it, but just so that you know that you can use the calculator to help you check and to help you create a table of values. It's very controversial, the calculator, in other words, right? And a lot of math teachers don't like students to use it because we want to see that you can graph by hand as well. But I'm asking you just to get familiar with the technology so that you can graph it both ways